Okay, well, welcome everybody to my talk here at GeeCON. I'm just so happy to be back, first of all, back to Poland, back to Krakow. Just really, really happy. This is my second time at GeeCON in person. So thank you again to all the organizers, to you, the audience, for coming. Thank you so much. Last time I came, I was talking about more reactive programming, and I was with IBM back then. This time, I'm actually representing DataStax, and I'm talking about event streaming. So, and specifically, too, I'll be talking about Apache Pulsar. I know it's kind of hard to see everybody. Has or have you heard of Apache Pulsar at all? Oh, maybe, a few. So that's great, thank you. And then how about, I'm sure a lot of you are working with Apache Kafka, I think, right? A lot of you are, yeah, I see more hands. So now, again, I'm not here to say, well, we're better and all these things. You know, after all, it's all open source. We try to cooperate. But I want to highlight why there is Pulsar and why it would be a good alternative for what you're trying to achieve, especially in a cloud-native type of environment. So, okay, so with that, let me start. A bit about myself. Actually, I have the point in here. Is that right? Or why is it not working? Oh, maybe because I need to point over there?
No, for sure not, but maybe we should change the window.
Oh, change the window. Okay, it's back there. Sorry, it was working before. Oh, there we go. Okay, somehow. Okay, thank you, Chris. Okay, so, oops, I don't know how okay, it changed back. But first of all, again, big thanks to GeeCON. And please send your questions to Slide.do and the GeeCON 2022 for the code, which I'm sure a lot of you already are familiar with. So please feel free to send any questions. And in fact, I do welcome very challenging questions. Sometimes we're still discovering what we should be trying to solve with a particular software or library or anything. I think no questions is silly. Any questions, all questions are great. So please feel free to send me any questions. So first of all, let me have a quick introduction about myself. I'm a senior developer advocate at DataStax. It's a company that, if you're familiar with Cassandra, they make database as a service called EstraDB in the cloud. And you can run it in Google, GCP, AWS, or Azure. And we have a $25 US dollar like credit. I'm not sure at this point, maybe in Europe. I think there are different regions too. So if you're interested, please let me know. I will try to find out. I should have done it sooner, but just didn't get a chance. But I think I should be able to enable a region for you so you can try that out too. You'll get an equivalent of $25 US dollar currency too for using it. And it's pretty sufficient for doing small application development. If you want to do something independent, it actually can work quite well. So anyway, so that's about me. And then previously, I was with IBM. I was with the Java WebSphere advocacy team before. I'm based in Chicago. I'm also a Java champion now. And I'm also an active community builder. I'm president of the Chicago Java Users Group. And I also want to invite you. Right now, we're still running meetups quite regularly. And it's all remote, although the time tends to be evening time in Chicago. But we also try to accommodate viewers from everywhere. Sometimes we do have evening time, like in your time zone too. So, and then I also have extensive experience in doing development work before becoming an advocate. I was about over 25 years, or actually about 20 years, doing more Java development too in various companies, including Chicago Mercantile Exchange and Bank of America, manufacturing company and cellular company too. So I kind of understand what it would be required if you're a developer in an IT shop, especially. And those are how you can get a hold of me, all the links too. But I will have, I'll be sharing this slide deck, so even if you miss it, don't worry about it. And this is just a picture, pictorially describing what I'm doing now, and primarily streaming, distributed systems, some reactive systems now, and I also worked a bit with IoT and MQTT as well. So today's talk is about Apache Pulsar primarily, but the thing is I want to bring out more is about event streaming, event processing, complex event processing, event-driven versus message-driven, and also like PubSub and queuing. Just clarify some terminology and understanding so we are all on the same page. And then also explain why event streaming, it is kind of becoming a hot trend this day as we all know, but there's a purpose of it being there, even though it's not as easy to do. And then I'll introduce you to Apache Pulsar, and also the Apache Pulsar, it depends also on Apache Bookkeeper and Apache Zookeeper too, for doing different kind of separation of concerns. So I'll introduce a little bit of those, and also how Apache Pulsar can extend Apache Kafka too, and why it is becoming important. So first of all, the many facets of computing events. I feel like it's good to first talk about, kind of get down to some basic, what is event, right? And generically speaking, it doesn't matter. We're not just talking about computers. We're talking about, in general, human beings. So events, right? So I look up the Merriam-Webster dictionary. The first one, something just happened, right? The first definition, it covers all ground. It's an occurrence, something that happens. And in computing sense, that means we need to do something about it. And then the fourth explanation, so there are different explanations, and then the fourth definition I thought is very interesting. It's actually taken from the theory of relativity. We have to represent events. So it's basically a fundamental entity of observed physical activity, and is represented by a point in the 3 coordinates of place. So if you're in the math inclined, there's X, Y, and Z coordinate. But for events, it's more interesting because it brings in the time aspect, in the space-time continuum. And that's actually interesting. That means you bring in a 4th dimension. And to me, that's always been fascinating for me. How do you do events? It sounds more easier. But actually, of course, as we know, it's not as easy to do because it involves time. There are different activities you need to react to it. And it's very often, too, and as I say all the time, is that when you're working with events processing and event streaming, it's all about asynchronous processing in a computing sense. And it's, of course, if we do asynchronous concurrency, parallel processing, it's always more complicated. You bring in a lot of complexity. How do you track it? And if we're just doing like some quick prototype, it may not be as hard. Events happen, you react to it, and there may be 10 events. But in reality, too, let's say in IoT applications, you can have devices keep sending a lot of messages. They become like streams of processing. Then it becomes really complicated, and that's where the fun starts. Okay, and so let's kind of have some definition for event stream processing. So basically, it's a practice of taking action on a series of data points that originate from a system that continuously create data. So that's kind of stream processing. So event, again, point to each data point on the system. And then stream is the ongoing delivery of these events. So there can be many events, and there can be parallel streams and everything. So a series of events can also then be referred to as streaming data or data streams. And then there's also the concept of complex event processing. So this is actually more kind of mimic reality now. We're dealing with like a complex situation in which, that's how we live. Basically, it's a set of techniques, right? It involves the techniques. So how do we actually capture all of the data and capture it and analyze that streams of data as they arrive, right? And what is it for? It's basically, for today's world, is to analyze the opportunities, or maybe like in cases in which there could be threats, there are computer fraud being committed, things like that. So you can actually set up different monitoring streams and then monitor any unusual activities, which I'm sure you are familiar with too. And then it basically enables systems and applications to respond to these events and trends and patterns in the data as they happen. And okay, so now then gets a bit into like event-driven and message-driven. Let's try to be exact. So I take this to the definition from Lightband, right? And Jonas Bonner was here yesterday, and he talked about another thing with Arca serverless, but still, Lightband is kind of the authority, so to speak, right? That they define the reactive manifesto, or they lead that definition and lead the reactive foundation, reactive streams, all of these things. So they are really one of the premier authority in this space. And I really like their explanation, like event-driven, there's some fine differences, right? Event-driven is basically sender will emit the messages, and the message, the sender doesn't worry about who will be receiving the messages. It's basically, it's kind of, if you talk about it, it's like pub-sub type of scenario. You publish your events, and it's up to the receiving side, the subscriber side, to subscribe to what is interested to them through a channel. And it's represented in Kafka as a topic, or Pulsar 2 also is calling topic. JMS2 is also calling a topic, right? So it's a channel. That's how you label your messages, and it relies on a broker to do that for you. Whereas in message-driven, then we're talking more about two parties, and sender and receiver. They have to know the addresses of each too. And very often they can be like bidirectional as well. So that's more message-driven. And the address have to be known. So that's kind of like the immediately some differences we can identify between these two. But they kind of still closely related to one another. They are doing, heavy, you're isolating, or kind of what you call isolation of concern, right? It helps, like messaging really helps with scalability too. That's the whole goal. Okay, and then let me kind of also step back a little bit. Even if you're not working with event-driven systems or any kind of events yet, there's this approach of events. Then how would the system able to handle events, right? So that's when, like in the older days, and actually in today's world too, it's still very popular, is doing batch processing. I'm sure some of you, or at least some of you are working with it, and it basically deals with data being collected, and then you process them in batch. So it implies a bit not real time. So event-driven approach is actually nice because it enables you to do real-time analysis, real-time processing, so you can get back the results as quickly as possible. So that's kind of the differences. Now, batch processing is still very important. For example, if some of you are in large companies, especially not just large companies, but companies that have to deal with processing like systems of records, big set of data. For example, I was at Chicago Mercantile Exchange. There every day, there are days, the trading, everything. So you need to collect all those and then clear them, right? Clear them is meaning that these trades are valid, and you do need to pass it to the, kind of manage who's going to pay for what and who's going to receiving. Are they all these things you need to clear the trade? So the clearing can be done like offline, so to speak, and you can do it at night. For example, it's more batch processing type of approach. Of course, too, right now with machine learning, too, I believe a lot too are still doing things in a batch processing kind of mode in which you collect a lot of data, you need to run your algorithms over it, and that's still being done in batch because the volumes of data is just too big. And from what I've talked with a couple of machine learning folks, they were saying that, wow, we got like terabytes of data, it's hard to go through streaming. But I think that there's a lot of potential of being able to actually leverage on a streaming platform such as Apache Pulsar. At some point, you can actually do real-time data analysis, which I think some cases are already doing that, but we like to kind of get more into this space because there are more and more need for data to be collected immediately and being able to process right away and give you that real-time dynamic feedback very quickly. Okay, so now then, let's take a look then into event messaging, some semantics and patterns. So some of you are also working with too, is doing the event-driven pub-sub kind of approach. So as such, there's pub-sub is the publisher sending the messages to a broker. And then it's up to the subscribing side or the consumer side. They need to subscribe to the topic in order to receive the messages. When you subscribe, doesn't mean the data is already there. So there's that time kind of aspect. So it's more like publisher, when they are ready to publish and they put data on the topic, then it's the broker, the in-between, the middle agent, get the messages, and then will distribute to all of the subscribers accordingly. So that's kind of a pub-sub approach. And think of it more like I like to think of, okay, if I describe, right, I have friends or that family, they're asking, oh, what do you do? And I'm saying pub-sub, nobody will know. So I would say, you know what, think of broker is like a post office agent. You need to go mail the letter, but in this case, it's slightly different. You don't really write the address. It's more like you telling the post office, okay, I have these messages to be sent out, and I have this topic. I use the topic to label it. So it's up to the broker, this post office agent, being able to distribute distribute them accordingly. And then when the subscribing client come, it will label that, okay, I want to receive messages on this topic. And so when the messages arrive, then the broker will deliver them accordingly. And of course, that's a simplistic case. In a really more complex real life pops up, then you have to define, right, the messages. Do you want to retain messages? Are there different time to live policy? Things of that nature, right? That can get to be quite complex, in fact. Okay, so that pops up in a nutshell. And then now let's get into message queuing. So queuing, too, is a form of asynchronous service-to-service communication used in serverless and microservices integration kind of architecture, too. So messages are stored on the queue until they are processed and deleted. In each message, too, that's the key, is processed only once and only by a single consumer. And it can be used for decoupling heavyweight processing, to buffer or batch work, or to smooth the spiky workloads. So that's kind of a definition I got. I think it's from the Confluent website. I thought that was pretty good. But one thing I like to point out too, in Apache Pulsar, it's interesting. Apache Pulsar, there's a broker, but you can also actually do queuing too in that architecture through the use of their subscription, because there are different subscription types. So you can actually subscribe to some topics, but you can say, I want to have exclusive subscription, so that particular topic and the subscription itself is only being delivered to that one client. So there's this exclusive thing. So that kind of turns this topic into a queuing kind of mechanism in this case. So that's kind of a bit of a difference that Pulsar is also able of supporting, is this messaging queuing, and also with pops up kind of a way of doing things. And then there are 3 other modes too of subscription too. You can have failover, or like a shared subscription, or then also a key shared subscription. And the key one is actually will preserve the order for you. So I'll get a bit into detail in a little bit. So there's just so much to talk about. It feels like even with the 45 minutes, it's actually not enough. So I hope kind of just give you an idea, and you can go do more research, and then we can talk more about it after too. So, okay, about event streaming. So then let's go back to like why we want event streaming. So I already kind of talked about it. It's basically the real-time data, that's what we're getting at, right? And what is good about it is, of course, it enhances your customer experience. Let's say I want to, order something. I want to kind of, send an order from my phone, and then immediately you get the order. The restaurant and will prepare the food for you. Everything will be fast without you having to drop what you're doing, and then you can have immediate result when it happens sooner. So that's kind of a real-time advantages of this data being made available to you. And then another thing is, of course, using event streaming for building data pipelines, especially for AI and machine learning type of work. And also it involves too, you want to build smart models too from like time series event streams too. So that's another also a big use case in this case. And then there's also scalability too. So if you think of like Internet of Things kind of devices, right? You can keep, using a pops-up kind of model. For example, I worked with MQTT before. This is message queue telemetry transport protocol. Maybe some of you are familiar with it. It's a very de facto standard of IoT messaging that uses a pops-up model too. So you can actually scale it really nicely, because you can have a topic being kind of dropped into the broker. You can have many messages happening, being delivered to different kind of subscribers all at once, and you can have multiple topics, and topics can, say in Kafka too, there's partition topics, or even in Pulsar too has this concept of partition topics as well. So scalability aspect. Okay, so again, I think here too is just an explanation. It's basically event streaming is you can watch for events with the system or application, and you can then, from a subscribing side, you subscribe to topics to see certain event types, and then make the decisions based on the data in real time, not after the event. One of the things too, I think maybe I can suggest too is, I know that in Europe, in Poland too, especially too, you're into soccer. So in America, there's American football. So we're talking about building an app in which you actually can, like during a game time, you want to see the real-time statistics of certain players. It would be nice too, right? If they are doing certain things, it's you collecting the data right away. Immediately too, you crunch it through some analysis, and and that can actually produce you some real-time player stats, then that would be kind of cool too. So that's something you can think of. If you're thinking about that, can kind of employ some sort of event streaming technique to help you to do that kind of work. So the idea is you want to be able to ingest high frequency of messages and then have a very low latency of response so you can get that being processed right away and get the results to your end user right away. So that's the idea. So now then, let me introduce Apache Pulsar. Okay. So what is Apache Pulsar, right? It is an open source, Apache Software Foundation open source project. It was first created by Yahoo back in, I believe, 2014, 15, in that time frame. And then they were, at the time, the engineering team were trying to use Kafka. Then they realized there's some shortcoming in Kafka that couldn't address their needs, because they needed to process their Yahoo Finance and all kinds of Yahoo services. And then they developed their own, this particular broker first, and then they eventually turned into Apache Pulsar. And what they did was, in 2016, they decided to donate it to Apache Software Foundation. And very soon, too, in 2018, already became a top-level project. And it's cluster-based. And so the nice thing about Pulsar is that it was already designed from the ground up to take into account that there are needs in a cloud-native type of environment. It's cluster-based. It's already designed to address like having multi-tenants on your system. So think of multi-tenants as you have your broker running, and then you have your tenants. They have the concept of tenants, and I can quickly show you in the demo side how you can do it using data stacks, the Cassandra in the cloud too, and I'll show it to you. You can easily create these tenants too. Multi-tenant, okay? And then there's also the client APIs is quite extensive too at this point. You can do Java client, you can do .NET, C#, Python, Go, Ruby. There are also community contribution to the client packages such as like JVM languages like Scala too is there. There's also Ruby, all kinds too. So, and anybody is welcome to contribute to that as well. So the key thing about Pulsar is interesting, like why is it kind of considered a bit better, is that because it has this separation of concern type of approach in its architecture. So say in Kafka, right, you have the compute side of things, it's managing all the brokers, all the messages. At the same time, it's also managing, because as such too, if you think of Kafka, Pulsar as well is a distributed logging. If you think of the distributed logging framework, right? You have tons of messages coming through. You need to have some ways of dealing with the messages, logging them. So Pulsar's approach is that it doesn't want to deal with all the, kind of complex, but yet, quite tedious kind of task of managing. So it delegates its work to this other library called Apache Bookkeeper. So Bookkeepers in Apache project, what it does is that think of it, you have to manage all your books for your business, right? You have to do accounting, all of these things. So it's basically delegating all of these bookkeeping, managing of all these log messages to Bookkeeper, because that's Bookkeeper's strength, is to do that. So it's separate out. So if you can think of it, then it helps in scalability aspect. Because every time if you want to try to increase the number of brokers in your situation, then you have to rebalance all of your topics, everything, because your topics might be partitioned into like different cluster. And that's one thing too about Kafka. If you have to handle that scalability aspect, it does get kind of quite complex. You have to manage that. So Pulsar already has this built-in because it has Bookkeeper helping you to scale to and immediately rebalance all of your different messages on different topics for you. So that's kind of, I want to point out, that's the advantage of that. And also too, being message broker, it also has guaranteed message delivery, like the QoS quality of service level. It supports 0, 1, and 2, so I'll get into that a little bit. And then also, Pulsar has a very lightweight serverless functions framework too. So let's say your broker, you have also messages go through, then how do you transform? You need to perform certain, or do some kind of transformation on the messages. Then there's also Pulsar function that can help you to do that. You can write serverless a piece of functions that you can put into your runtime that will help you too. And you can also do it through the Astra DB console, which I'll kind of quickly point out to you too. And then essentially, too, it also has a tiered storage offloads, too. So it manages all of the data, right? You get so much data, it gets overwhelming, and then you need to kind of periodically do some transferring of that over to some archive kind of places. So it does it for you automatically. So think of it as kind of nice, right? Because as developers, we don't want to deal too much with housekeeping, all of these things, and basically Pulsar can help you with that. So, okay, oops. Okay, so this is another slide too about what is a bit more about Apache Pulsar. I already talked about Yahoo and it's cloud native. Kubernetes, it runs on Kubernetes and it's multi-cloud. And on-prem too, even if you have on-premise, you want to put Pulsar in, actually it's very nice. Pulsar is quite flexible. You can use it as kind of a bolt-on thing into your existing kind of infrastructure too. And then there are actually 4 reasons too that actually our field team that they put together. So I wanted to share with you why Apache Pulsar can be essential to the modern data stacks too. And as you can see too over at all the graphs I was just going to show you is that there's an increase in the number of interests, right, of people contributing or putting a star on the GitHub repository. And even I think the latest, this statistics is a bit older, is from 2021, so almost a year ago. But you can see too even the number of contributors are increasing that has kind of gone over that of Kafka too. So I think people are starting to realize the potential that Pulsar can do. And then if you're curious too, who else is using Pulsar? Of course, Yahoo, Comcast, and Splunk, all of these companies, as you may recognize, Verizon or GM, and some of the mainland Chinese, Tencent, I think those are big companies. They are actually using it quite heavily. There's also, interestingly, I recently found out if you are into database, there's a concept of vector database, right? Vector database is good for, especially doing machine learning algorithms. And there's a database called Milfus. So Milfus actually uses Pulsar underneath the hood for doing their heavy event-driven processing too. So if you're interested, yeah, it's just not listed on this. So, okay, so this is another slide too about brief history, which I already explained. So it started off 2016 and now 2022 already, and it's going strong too. So I wanted to point out. And Pulsar is different, wanting to quickly kind of point out. So Pulsar component has producer, consumer, just like a lot of pops up system, right? The broker is stateless. It's a stateless process that handles incoming messages and message dispatching, communicates with the Pulsar configuration store, and store messages in the bookkeeper instances. So there's bookkeeper that helps with managing, persisting all of the log messages. As you can see too over here in the diagram is that you can have, producer, consumer, there are different brokers. You can have multiple broker instances that get kind of dropped everywhere accordingly, right? And so it has the mechanism of managing all of these multiple brokers for you, because if you get too many messages, you do need multiple brokers to handle all of it. And then it will nicely, on the bookkeeper side too, it will segment out all of the storages of all these tons of messages that it manages for you. And also too, it uses Zookeeper. The Zookeeper is to manage like cluster management, handles the coordination tasks between Pulsar clients and all of these things. So that's what Pulsar uses Bookkeeper and Zookeeper for. And this is just a quick diagram too of the tiered architecture design approach to traditional like multi-node architecture in here. It supports like horizontal scaling and partition topic abstraction. So it masks all of the complexity from consumers too. So common challenges, right, of if you are getting into multi-cloud, into a cloud native environment is if you want to scale, always, right, the partition part, you need to have very careful rebalancing. If the framework doesn't do it for you, then you have to do it yourself, and it's not trivial at all. And so Pulsar has that built in already for you. And then there are also tightly coupled persistence and message serving capabilities, right, that can be tough, right? Say in Kafka too, it doesn't separate out the persistence and message serving capabilities. So it makes it harder to manage if you have to do this kind of rebalancing yourself. But again, Pulsar can do that for you. And then basically too, if this is the case, that means Pulsar can spend more time on serving the messages rather than worrying about the bookkeeping at the back end. So. This is another diagram too, and architecture to kind of explain to is basically what's the big deal, right? You were kind of asking. So it helps, right? It's fast. All of the scaling can be done faster. Broker is stateless, built-in load balancing, instantaneous scaling, and if you want to do recovery, disaster recovery, it's basically zero impact too. And again, Bookkey too. I wanted to just quickly point out the Bookkeeper is scalable and wall-based, which is a write archive specification, like it is conformed to that specification, and fault tolerant too, and low latency storage service. And if you're into message replications, there are like ensemble size, write quorum, act quorum. It gets into these fine details of how you manage all of these complex set of log messages too. And it's fast write, through their journaling kind of mechanism, and also they have their ledger to deal with segment-centric data persistence as well. Okay, so these are just another kind of a repeat of, Apache Pulsar basically represents the next generation of enterprise messaging, distributed messaging in the cloud-native environment. It's basically a unified solution. You can do PubSub, you can do queuing, streaming, message remediation, mediation and enrichment too. And out of the box too, you can also, I mentioned about multi-tenancy. There's also geo-replication too, which is kind of interesting too if you're managing especially big corporation, for example. If you want to do data lake integration, all of these. So that's why I think DataStax has chosen Apache Pulsar, because DataStax, again, is a Cassandra-centric company, is really where they're bundling up the open source Cassandra on the cloud and everything. So we kind of bring in Apache Pulsar to enable the streaming from Cassandra. But this is that. And this is essentially the same picture in here. But this one too, just another diagram to explain to you the idea. Pulsar being like kind of the center, and then you don't need to change everything if you don't want to change. What you are running now in your company on premise and everything, you can actually use Pulsar as the unified solution kind of provider too, and that's the idea. This, I think, is also the same thing, distributed. Tiered architecture separates compute from storage and then uses Zookeeper to hold the metadata for the cluster. And then stateless broker will handle producers and consumers, and storage is handled by Apache Bookkeeper. And these are like a rich ecosystem of connectors and clients that you can think of. So it's kind of nice. You can build data pipelines and everything, and it can also work with other libraries and framework. And actually, there's still a lot of ongoing effort right now, talking with a lot of vendors that we're building out connectors to. One of which actually was last night. I was at Speaker's Dinner, I think Michael, and we're talking about Quarkus. We're going to have Apache Pulsar connector to Quarkus, things like that. Right? We're kind of working on all of these too. Okay, and then just again highlighting to multi-tenancy and zero downtime, and it's really designed to be very efficient. There's also security side, it's pluggable authentication. You can have TLS authentication, JOT, OAuth, and all these curb row-based, authorization, all of these things, managing your clusters, your tenants, message producers, and consumer level. So it's already kind of built in with this cloud-native mindset in the whole framework itself, and has end-to-end encryption too, with using TLS. Okay, and so basically wanted to point out too, so highlighting, right, if you have to kind of decide what to use, why do you want to pick Pulsar? So you can kind of be aware too, there's a separation between compute and storage, as I mentioned about it. So over here, it doesn't seem like if you're just dealing with a smaller system, smaller set of data flowing through, it may not be a big deal. If you're dealing with actually heavier systems, right, if you are in the machine learning or even like big data processing, managing IoT kind of data and all of these, you may want to consider Apache Pulsar because, again, right, they manages the message serving separately. So then it's a bookkeeper that manages all of the logs. So it helps too in this sense, right? And basically, Apache Bookkeeper has this segment-centric like message storage management. So then in some ways too, you don't need to worry so much about all of the logging that's behind the scenes kind of thing. So it's delegated to Bookkeeper. And it helps too in this case with horizontal scaling. If you have more processing coming in, more requests coming in, basically that can be spread out across your different partitions and everything, and you're focusing on your programming side, you can focus more on the message serving, the compute side, while you know that Bookkeeper is helping you with managing all of those logs and everything. And with Bookkeeper too, you can also configure it accordingly as well. And then the next thing too is about being geo-replication side is also a native thing. It's already been built in. In Europe here, for example, you have GDPR data like that. So if you have big companies that you have different parts of the world that's operating, you can actually do a lot of kind of configuration to manage some of these regional specific, or in the world you have different rules and things like that. You can actually do that through kind of configuration too. And so in this case, it's, like I said, I cite an example of GDPR, or maybe in Latin America, there's another set of rules. I think in the US, it's still very relaxed. There's no such rule yet. There's increasing number of rules, but I think California is the first one with more like privacy kind of control. So that kind of stuff, you can actually control it. So then maybe you are doing certain things that you want to make sure that, specific data is being applied to certain regions. Things like that. So that's all kind of available within Pulsar that you can configure and manage it that way. So yeah, and then it kind of basically help you with data compliance requirements across many geographic regions too. And then there's also this concept of multi-tenancy. So if you think of a Pulsar cluster, you can divide them up into different tenants. It's kind of help with administering kind of different units of kind of administering too. And it, with different ways, you separate them out. That means it's kind of, think of it, you are in an apartment building, and then you have different units. And so the different units has its own bathrooms, its kitchen, and all of these is self-sustaining. Likewise, right, in a multi-tenancy in this case is that you are part of a cluster, but you don't really care. I'm just a tenant, I live there, and I have all that I need within it. And the framework will handle a lot of the, framework level things for you. So you don't need to worry about, if the water supply is not there, you need to have, somebody to take care of the plumbing, that type of stuff, right? Think of it like that, kind of an analogy. So they basically, a Pulsar cluster will handle all of these things for you, while you only are concerned with your own unit of operation within the tenant. And then there's also the flexible message processing. I pointed out earlier about 4 modes of subscription. So there's exclusive, which is kind of a form of queuing. So the queuing is that the subscription is only meant to be for one customer, and then or one recipient, one consumer. So think of it more like a queuing kind of mechanism in some ways, right? And then you can also use a mode called failover. Failover is in the case in which you have multiple, or actually you can have 2 consumer in this case, and then if it's only the primary one always receiving messages, but for some reason that primary consumer goes away, then you have a backup. It fails over to the second backup consumer. So that's failover. And then there's also shared subscription. So shared subscription is basically that subscription you define for the topic, the producer, and your consumer, but that particular subscription is can be shared among more than one consumer. So that's helpful in a cloud-native type of scenario if you want to do client load balancing, things like that. So that would be useful for a shared subscription. Now, if you want to make sure that messages come in and they are receiving in the right order, then you might want to use key shared subscription type too. So that's also that options as well. Okay, so now then, let me quickly kind of take a look, right? So why Pulsar? So there's been some studies, too, that are kind of comparing Kafka versus Pulsar. So if you're interested, you can visit those links to up there. There's those articles written up about them. But basically, when you should consider using Pulsar is if you need both queues, like RabbitMQ, or stream processing, like Kafka, you might want to use Pulsar that will actually offer you queuing and pubs up at the same time. And then if you want easy geo-replication, right, and multi-tenancy, right, it's very important to you, then you might want to consider Pulsar. And then if you need to persist all of your messages for a long time and you don't want to offload them to another storage, all of these kind of more framework level kind of managing of all of these data movements and all that, that might be good. And if performance is critical for you and your benchmark have shown that Pulsar provides lower latency and higher throughput, you might want to consider that. And if you're running on-prem and you want to use a more modern messaging infrastructure, you might want to consider Pulsar because you don't need to change your on-prem, your JMS, you can still keep it too. Then you can put both on Pulsar on top too. Okay, some of this is just DataStax flavors of Pulsar. These are just marketing thing. I think I already showed you that, picture. And then there's also, in DataStax 2, we have what we call Astra streaming. It's a managed Cassandra database, but we support streaming, and that's through Apache Pulsar. So that's Astra streaming. Again, we offer you a starter, like a free number of credits. So again, here in Europe, let me get the code for you if you're interested in trying. That's the managed Pulsar. But otherwise, too, there's different pricing infrastructure, too. Now, if you want to use the open source version, you can actually use Luna streaming. That's also like coming from DataStax. You can use it all for free, but if you'd like to have any kind of enterprise support, you can purchase them separately, too. And then if you want to go all open source, of course, you can use Apache Pulsar, kind of community-driven thing. And then there are different, there's the streaming, Astra streaming offerings. Again, we have Luna streaming and then Astra streaming. As you can see, Astra streaming is a fully hosted kind of scenario. But for Luna streaming, then you have to host it yourself. But then you can have support from DataStax too. So, and then Astra streaming is coming very soon. We are still seeking for some early access participants. So if you're interested, please let me know. And how is Pulsar different from another messaging platform? Just things to be aware with Kafka, I just want to quickly point out, right? Again, I point out too already is that scaling Kafka can be tricky because it has a tightly coupled kind of architecture with the compute side and the logging side too. So it can be tricky if you try to scale it, if you want to design it. And if every time, as you know, with Kafka, you have to know ahead of time how many topics you have, how many partitions, all of these things, right? And it's can't do it dynamically. So it's a bit of kind of heavier, kind of upfront thing you need to work with, say, with Kafka. So because Kafka was designed not so much with the cloud native in mind, so then it doesn't kind of scale too well, in more of the, today's kind of cloud native explosion. So I would say is that. And then and there's a primarily like cluster rebalancing can basically be tough for Kafka. But then Pulsar already has this built in, so it makes your transition to doing this kind of rebalancing much easier too. So I think I only have like 5 minutes left or so, but these are kind of, again, comparing these. So I will quickly kind of show you Astra DB, and then also how you can define some streaming. So let me do that. And these, I think we already show. These are just different diagrams of comparing Pulsar, and then with Kafka too, if you want to take a look. And here is a quick demo. So I'll just quickly kind of switch over here. Let me see. Now I gotta see what I can. Okay, and I think, can I? I think maybe I'll just, let me drop it over there. Okay. Yeah, okay. All right, this one, right? Can you see? Okay. All right, so this is actually Astra. This is just harder to do. But okay, so if you go to astra.datastax, is it? Oh, that's right, thank you. I'm still not used to doing in person, right? Because it's just coming back to in-person conference just, a month ago. So a little bit kind of rusty, because I've been doing online presentation for a long time. Seems like forever. So this is our Astra DB. So if you go to astra.datastax.com, and I have the link later too. So you can actually sign in, and right now, right, do it again. I already have created an account, but the thing is, if you haven't, please feel free to create an account. I think it's immediately, you should still be able to create an account, but again, if you get to actually creating a database, if you run into problems, please let me know, because I can do all of the multi-region thing. I can get the code for you too. So as you can see in here, it's actually quite easy to do, right? First of all, do something about Cassandra first, right? So you can actually create database. Quickly create a database, and it's basically too, you want to create a database, give it a database name, the key space name, and then you can pick, GCP or AWS or Microsoft Azure, and then quickly you can create it. Now, for now, I won't create it because I've already created it, but if you're interested, please go ahead and try it out yourself. But let me kind of quickly show you too, because it would take some time when the cluster to be ready. Not too long, maybe a couple minutes, but I don't have as much time. So over here, I created a bunch of things. I'm already doing a couple of demos and things. But for today, I just want to show you, right, Apache Pulsar. If you want to create a tenant, basically a streaming tenant is as easy as you can just go over here, go to the streaming, and then create your tenant, give it the tenant name, give it the provider, anything, right? You can do a GCP or AWS or Azure, and then you can quickly create it. So it only takes like a few seconds for you to do it, and it will take maybe a minute or two for it to be up. And then once you have it, in my case, I already have it. So I have, for example, this thing is I created, oh, you know what? I actually, this is hard to do. Let me see. Okay, over here. There are also different organizations too. So I already created one called Data Stack Swim. This happened to be a proof of concept I'm doing. And over here too, it's nice too, you can actually create different organizations. So kind of think of it, you can have different purposes you want to create for your demo purpose, and you can actually create different organizations and then create the database and all the streaming within it too. So over here, right, if you I already creating something called like a POC tenant for doing my work. So over here is nice because you can go over here and then my tenant's been created. It gives you all of the access kind of endpoint you can use, right? And then all of the authentication too, you can immediately generate all the tokens too. And it's actually, when you create it, it already creates something default for you too. So I already created some of these, and then you can use the tokens from here. It's pretty easy. And then over here, if you want to create a topic, if you go over here, a topic, and over here is their default namespace, and I already created one called Topic Swim over here. And again, creating topic too is also not very complicated. You just create it, it's there. And then you can then immediately start using it. So now, in order to, I'll show you too. Actually, this one over here. Yeah. Now, if you go back to this tenant detail, there are different examples of how you can do the connection. So, for example, we're a Java conference, or if you do Python or Golang, we have already some example for you, even if you have JMS2. JMS2, for older libraries, we're using a library called Starlight library too, that DataStax has that help you too. If you're interested in that, let me know. I can give you more information on that. But for now, let's kind of take a look. I only have 2 minutes. So there's Java too. So it will show you, right, the Maven, how do you connect to it, and all of these things, like over here, right? And then if you want to do producer code too, we also have like a boilerplate producer, how you can do it. It gives you already your URL and how you can create a simple producer. For example, right, any kind of pops up is you do a client connect, and then once you connect it, you get, give the authentication, and then you immediately can then define your producer, and then basically create that topic, right, doing this, and then immediately you can use it, right, and do a send, and that's how you publish. That's like the simplest case. And if you want to do consumer, you're like, okay, I want to see how to consume it. So consumer side too, will have the code that kind of tell you how to do it. And again, a connection. The difference is that you do a client new consumer and then connect to that topic and give the subscription name or subscription type, right? I talk about exclusive or doing like failover and all these things. You can do it there. And then basically then just do a consumer receive, and you should be able to then receive. Now, right now I only have 1 minute left. I was trying to also show some code. I think I may not have enough time to do the code. But if you're interested too, why don't I go back, because I don't want to hold up. This room's probably going to be used by someone. So let me go back to here and finish this up. But if you're interested in more information too, so where to go, right? This is all the links that you can get. Again, I'll share the slide deck. Then you can reference all of these things from these links. I have more links too. So now the thing is that I'm on the internet, so I can give you how you can the different endpoints or address you can reach me. But for now, I want to invite you to sign up for Astra DB. So that's the managed Cassandra in the cloud, and from which you can use the Astra streaming that is actually Apache Pulsar underneath the hood. And then if you're interested too, there's also an additional $200 in credits too if you use open source 200. Again, if you have issue with that, let me know, because I can get the proper code for you if it is for a different region. So. And then this one, that's what I wanted to point out is I also do a Twitch stream, a weekly Twitch stream. So even though today I don't have time to demonstrate everything, I'm working on a proof of concept. So I'd like to invite you, if you like, every Wednesday at 2 p.m. Central Time, US, which is like 9 o'clock your time, evening, I have my Twitch TV show on. So if you're interested, you can join me there too. I would love to interact with you. If you want to get on the screen and talk about things, I will be very happy to add you to my stream, on kind of pop-up kind of basis too. So please consider following me on my Twitch. Okay, there we go. And then because Apache Pulsar is still kind of new, so I don't have as much of a connection to give you right now, but we do have meetup.com. We have set up some meetup groups. And then also there's a site we're developing called Apache Pulsar Neighborhood. So we're trying to get everybody to join us there. And with that, that's all I have. And thank you so much. I know I talked too long, but I didn't have as much time to demonstrate. But thank you all for coming to my talk. And I think, should I be answering questions?
Yeah, we should. Let's
something, right? Okay. All right. Yeah, let me quickly answer. Can we use Pulsar in non-cloud distributed infrastructure, which contains microservices and modular systems? Yes, you can. Okay. And then is Apache Pulsar production ready? I'd say it is. Yeah, there has been implementation. I need to give you some example if you're interested. Yeah, it is production ready, but I do have to say there's still a lot of work to be done to make it full-blown. But I do believe it is the streaming platform in the near future. So, okay. Isn't it yet another event processing tool? There are many existing, like Apache Flink, Spark, Kafka Streams. Of course, yes, there are so many out there. But I like to still emphasize that Apache Pulsar is so much of a cloud-native minded, right? Managing clusters. Again, the separation of compute and log messaging, I think that's a really, really big advantage of Pulsar. So, okay, what is the performance cost of auto-repartitioning, rebalancing for Pulsar in comparison to Kafka, which has it fixed? So, it is, cannot quote you the exact cost, but for sure, too, I think to do the repartitioning and rebalancing, as I'm sure you are aware of, can be very costly because if I have to write the code, and do all these things and test and everything, it can take weeks, if not, kind of months. So I'd say it is actually a big advantage if you consider using something like Pulsar to help you to do that. Okay. Is there a size limit or recommendation for size of data in events? Streaming larger data might be complicated. It is. I do agree. There is a size limit, although I have to look up to exactly to tell you what it is. But for the most part, it shouldn't be like, if you're not doing petabytes of data, I think it should be able to do it. But I will look up the answer for you. And please follow me on my Discord, and then. Yeah, and it's over here, my Discord. And we can continue the conversation too, and I love to have more conversations on this. So, and you can share with me your projects as well, and I'm learning from you as well. So I think those are the questions. Thank you so much again, and really appreciate you coming and joining me today. Okay, and please take care. Thank you. Thank you.